Welcome to APSC 2008, Digital Electronics and Computer Interfacing. This course contains 4 modules. As you know, this course doesn't have any prerequisites. So the first module is going to be the basic concepts, the fundamentals of electricity. What can you expect from this module? By the end of this module, you will be able to explain electrons, electric charge, and its property when it's static and dynamic. And further, you will be able to understand and calculate current, which is the flow of electrons, and voltage, which is the force that is required to push these electrons through a conductor or through any element, and power from one another in a circuit. So when I say a circuit, in the first module, we will be talking about household circuits, and this course following that, like say from the next module onwards, we'll be talking about electronic circuits, and maybe a little further, like we'll be talking about like logic circuits in the later modules. Following that, you will also be able to recognize the difference between direct current and alternating current systems. In addition, you will be able to calculate the electrical energy and for different purposes, and by that you would be able to better understand the utility bills. And the next one is you will be able to assess your needs and make informed decisions while making purchases of electrical appliances and machines. So let's say if you wanted to purchase a fridge or a freezer or a television, this would help you make informed decisions while purchasing those. So let's get started. So atoms are the basic unit of all matter. Atoms are made up of the nucleus, which contains protons and neutrons, and the electrons, which are kind of orbiting around the nucleus. Protons have positive charge, neutrons have no charge, and electrons have negative charge. So in a neutral atom, they have equal number of protons and electrons. So in this case, we have 4 electrons and 4 protons. They balance out and they are neutral. Let's imagine an electron is being removed from this atom. Then there will be 3 electrons and 4 protons, making this a positive charge. If I add an electron to this atom, you can ask a question like how that is possible. Again, as an atom, it might look weird, but like say in a molecule, there might be some holes, like in the lattice structure, there is a possibility. And in that case, like if you happen to add an electron to an atom or a molecule, and the net number of electrons is going to be greater than the number of protons, so making that atom or a molecule positively charged. So that is an electric charge. Let's understand a small experiment. You can try this experiment with your kids to explain electric charge. So an acetate strip and a vinyl strip is what is required for this experiment. You could purchase this off the internet. And let's take these strips and briskly rub with a woolen cloth. So what happens once you do that and pick up 2 vinyl strips by one end in each hand, and you bring them together slowly and repeat exactly the same step by holding one vinyl strip and one acetate strip. Again, these strips are charged by rubbing briskly with a woolen cloth. The charged strip, you put them 50 centimeters apart and slowly bring it close together. What happens? So here, the two charged vinyl strip will repel each other. That applies to acetate strip as well. And when I say repel, they will try to stay apart. So this is very similar to a magnet. So when you place two north poles together, they repel. When you place a north pole and a south pole of a magnet, they attract and they stick together. So exactly the same thing happens here as well. Likewise, if you take a vinyl strip and an acetate strip, they attract each other. So the law of electric charge states that like charges repel and unlike charges attract one another. Rubbing, so what happens here is, like when you rub the vinyl strip with a cloth, some of the electrons from the vinyl strip is moved or is transferred, some of the electrons from the cloth is transferred to the vinyl strip. So if you see the net negative charge in the strip, it's going to be higher than the positive charge. So since the cloth has lost some of its electrons, the cloth is going to be positively charged. Likewise, with the acetate strip, when you rub them, so the cloth will remove some of the electrons. This is exactly opposite to what happens in a vinyl strip. It removes the electrons from the acetate strip, and because of that, the cloth becomes negatively charged because the number of electrons here in the cloth is going to be higher than the protons, and in the strip, because it has lost an electron, it is going to become positive because the net positive charge is going to be higher. So this is a good experiment to do with your class, or like to experiment to understand electric charge. There's another experiment called the electroscope. You would be able to build one of these with a mason jar and a copper wire and aluminum foil actually. So that should be more than sufficient to build a setup very similar to this. So what happens? So if you take a balloon, blow them up and rub it against your head, it's going to charge up. It doesn't matter whether it is positively charged or negatively charged here. When you bring a positively charged balloon close to the brass disc here, this is going to be neutral at first, but when you bring them in, still it will be neutral though. When you bring the positively charged balloon close to the brass disc, the positive charge will repel all the electrons in the brass disc, and the charges are going to flow through the wire or the brass rod here, and it's going to move to the leaf here. Actually, this is a gold leaf here. It could be an aluminum foil that is like cut into a leaf. So what happens is, like when you have electrons on both of these leaves, so there's going to be a repulsion because of the law of electric charge. Say they're going to repel and try to push from each other. As soon as you remove the balloon, it'll go flat again. Due to gravity, it's going to come down. Even if the balloon was negatively charged, what is going to happen is, like when you bring it close to the brass disc, or instead of negative charge, let's say it is positively charged. So when you bring them close here, it's going to attract all the electrons. So the electrons from here in the leaf is going to move. So both of these foil are going to be positively charged. Again, the same thing happens. Positive charge, like charges repel, and they repel and like move together. So move apart from each other. So this is another experiment like that could be made with a simple mason jar, aluminum foil, and copper tube to explain electric charge. A very common thing that often happens during winter is, like, say, when so this is a typical slide that you will find around, or even when we walk in a carpet, due to friction, sometimes our body gets charged up, and the charge doesn't matter whether it's negative charge or positive charge. If our hair strands are charged up, so they are going to be having the same charge, and that is going to repel each other. So the hair kind of lifts up against the gravity, and like say this is how it will look, a little messed up. Another example of charges is when clouds are having a draft. So because of the temperature difference in the cloud, so up higher, like the temperature is going to be really low, and very close to the ground it is going to be high. So this change in temperature will have the molecules, hot molecules, or like which is having less temperature, the molecules, the water molecules and air molecules that has like less temperature to move up, and the cold molecules to move down, and this will create an updraft and a downdraft. So because of that, there will be some friction, and this friction will cause the electrons to be ripped off from the atoms or molecules, and it will create a charge. And when this charge is really high, like so the potential difference becomes like really high, then the insulator, which usually doesn't conduct electricity, will break down, and that breakdown is what we see as the lightning bolt. So this is electrostatic as long as there is a difference in charge. There will be an electric field and there will be an electric potential, but it can't stay in that state forever. So when it breaks down, it becomes neutral. The cloud becomes neutral, and because of that, you will have a lightning bolt. So that is electrostatics, and until like it breaks down. But like when it breaks down, the electrons are in motion. So that is electrodynamics. So here it is uncontrolled, but like we wanted to really control them and make use of that to transfer energy from one place to another and do some useful work with that. So we will talk about electric current in the next subsection.